Good day, everyone. Welcome to my video learning with Bahagharing Lexi. And this day, what we are going to discuss is all about solving rational equations. And with this presentation, let us go with what are the expected competencies. Now, at the end of the session, learner is expected to find the factors of the given polynomial expressions. 2. Determine the least common multiple. And 3. Solve rational equation. To start with our presentation, let's have fun. Now, determine the factors of the given polynomials by matching column A to column B. I will be giving you polynomials in column A, and these are 3x minus 9, x squared minus 4, we have x squared plus 2x minus 3. We have x squared minus 25. And we have x squared minus 3x minus 10. On the other hand, these are the following factors. And we are going to match our column A, which is the polynomials, and then match it to column B, which are the factors of the given polynomials. Okay? Now, for A, we do have x plus 3 and x minus 1. For letter B, we do have 3 and x minus 3. For letter C, we do have x minus 5 and x plus 2. For letter D, we do have x plus 5 and x minus 5. And for letter E, we do have x minus 2 and x plus 2. Okay, now I will be giving you 1 minute to answer the given exercise. Okay, now we go with the given exercise. Now we are going to match column A to column B. Now for number 1, what are the factors? Okay, the factors are 3 and x minus 3. That is letter B. Okay, for number 2, we do have, okay, letter E, which are x minus 2 and x plus 2. Okay. Next, for number 3, we do have, okay, letter A, x plus 3 and x minus 1. Okay, now for number 4, we have letter D, x plus 5 times, or x plus 5 and x minus 5. And for number 5, we do have letter C, x minus 5 and x plus 2. Okay, now we able to find out, or we able to determine the factors of the given polynomials. Okay, now this concept will be utilized when we are going to solve rational equations, because there are cases wherein we are looking for the value of the given unknown, where we can factor out the given expression and then apply the zero property of equality. Sometimes this factoring concept of the given polynomial can also be utilized when we are looking for the least common multiples. Let us continue our fun activity by doing this another set of exercise. This time, we are going to determine the least common multiple of the following expressions. Now, here is the first set of expressions. 2x, 5, and x squared. What will be our LCM? Okay, very good. It's 10x squared. In the given expression relative to the numerical coefficient, we do have 2, we have 2, we have 5, and we have 1, which is invisible. Now, the given 2, 5, and 1 have common multiple, which is 10. Okay? The first product, the first product of the given number by counting numbers, which is common to 2, 5, and 1 will be 10. Thus, in a given 10x squared, 10 will be our multiple for 2, 5, and 1. On the other hand, for the variable x, we are going to what? We are going to use the variable with the highest exponent. Thus, since this is monomial, therefore, we are going to use x squared. Thus, the given LCM here is 10x squared. Now, what if we do have x plus 2 and x minus 2? Okay, now what will be our LCM? Okay, now the LCM here is x plus 2 times x minus 2, or also equal to x squared minus 4. Okay, you may use x plus 2 and x minus 2 or x squared minus 4. Okay, next, what if we do have x squared minus 1 and x plus 1? Now remember class, x squared minus 1 do have factors x plus 1 and x minus 1. Since we do have x plus 1, which is common to x plus 1, thus, we are just going to write it as x plus 1 as a single. Then multiply to the remaining factor of x squared minus 1, which is x minus 1. Thus, the given LCM here will be x squared minus 1, or x minus 1 times x plus 1. Okay? Next, we do have x minus 5 and x plus 5. Therefore, the LCM will be the product. Okay? And it can be x minus 5 times x plus 5. And last one, we do have x squared minus 25, x plus 5, and x minus 5. What will be our LCM? Now remember, x squared minus 25 do have factors, which are x plus 5 times x minus 5. Now, x plus 5 is common to x plus 5. X minus 5 is also common to x minus 5. Therefore, since we do have 2x plus 5 and we do have 2x minus 5, we're just going to treat it as a single expression. Therefore, our LCM will be x squared minus 25, or x plus 5 times x minus 5. Knowing this concept of finding the LCM, now this can help us in solving rational equation. Okay. Now, the question here is, what is a rational equation and what are the example of rational equations? Now, I do have here some of the examples of rational equations. Looking in the given examples, now, all of these have rational expression. But as a rational expression, it contains a polynomial in the numerator and polynomial in the denominator, meaning it can have at least one rational expression. But in my given examples, all do have contain not only one rational expression. Okay? Now, what is rational equation? Rational equation is an equation containing at least one rational expression. Okay? With a polynomial in the numerator and denominator. Remember that in a given rational equation, make sure that the given numerator and denominator are polynomial. Okay. Now the question here is, how do we solve for rational equation because we do have variable. And remember, the main objective of rational equation is to look for the unknown that will satisfy our equality. Okay. Now, here is our guide in solving rational equation. How to solve rational equation? Number one, find the least common denominator. We're able to recall the concept of finding the LCM, and that concept will help us in finding for the LCD because the principle under the LCD is the same with the principle of LCM. It's just that we are looking for the LCM of our denominator. Next, after getting the LCD, we have to multiply both sides of the equation by the LCD. Okay? And then solve now our equation. And last one, always check your solution, meaning the value of the variable should be verified so that we can determine if our solution or the value of the variable is extraneous. And if that will be the case, then that will not be the value of the variable nor solution of the equation. Okay, I repeat, how do we solve rational equations? First, find the LCD of the given denominator. Whatever be the LCD, multiply both sides of our equation by the LCD. Then solve the equation. That is to find for the value of the unknown. And whatever be the value of the unknown, verify if the value of the variable is an extraneous solution. Okay? Now, let's proceed with our illustrative example. I have here over x minus 3 over 2x is equal to 1 over 5. Now, in this case, as always, we have to follow our procedure. And that is, first, get the LCD. And in our illustrative example, our LCD will be 10x. Okay, it's 10x. Remember, 2 and 5, our LCM for 2 and 5 is 10. And then for the variable x, then we are just going to multiply 10 by x. Thus, the product will become 10x. Therefore, our LCD is 10x. After knowing the LCD of the given rational equation, we have to multiply both sides of the equation by our LCD. And that will be 2 all over x minus 3 all over 2x is equal to 1 over 5. Multiply both sides by 10x. And then 10x, okay, 10x divided by x is 10 multiplied by 2. Therefore, we do have 20. 10x divided by 2x multiplied by 3. Okay, we do have 15. 10x divided by 5, we do have 2 multiplied by, we have 2x rather, then multiplied to 1, we have 2x. Therefore, we do have 10 times 2, 5 times 3, and then 2x times 1. Next, 10 times 2 is equal to 20. Then 5 times 3 is equal to 15. And 2x times 1 is 2x. Next, 20 minus 15 is 5, is equal to 2x. Now, 20 minus 15 is equal to 5, is equal to 2x. Next, the numerical coefficient here is 2. Therefore, divide both sides by 2. Thus, our value for x will be 5 halves or 5 over 2. Then we have to verify if our value for x is extraneous solution. And if not, therefore, that is now the true value of the given unknown. Okay, now we are going to verify if the value of the given variable is really true to the given equation. Otherwise, it will not be our value because that is extraneous solution. Now, I do have here the checking for the verification of the value of the unknown, which is 5 hubs. Now, by substitution, we do have 2. Here is 2. Our x is 5 hubs minus 3 for the numerator. Then we do have 2 as a multiplier. Multiplied to 5 hubs is equal to 1 over 5 or 1/5. Next, 2 and 2 can be canceled out, or if you want to, 2 times 5, 10 divided by 2 here under the given denominator of 3. On the other hand, we do have 2 all over 5 halves. And this can be written as 2 all over 1 divided by 5 halves. Then copy minus 3/5 is equal to 1 over 5 or 1/5. Next, 2 over 1, then change the operation to multiplication. Then if you change the operation to multiplication, then you have to get the reciprocal of the fraction or the inverse of the fraction. Therefore, that will become 2 over 5 or 2/5 minus 3/5 is equal to 1/5. Then 2 times 2, 4. 1 times 5, 5 minus 3 over 5 or 3/5. Therefore, the answer will become 1/5. Thus, 1/5 is equal to 1/5. Meaning, the value of the given rational equation relative to the variable x is equal to 5 halves. Okay. Next, another illustrative example. I do have here 2 all over x squared minus 1 minus 1 all over the quantity x minus 1 is equal to 1/2. As a ruling, we have to get our LCD. And the LCD will be 2 times the quantity x squared minus 1. Now, why is it? Because the factors, remember, in the previous exercises that we had, the factors of x squared minus 1 are the following: x minus 1 and x plus 1. X minus 1 is similar with one of the factors of x squared minus 1, which is x minus 1. That's why we are just going to treat it as a single factor. Then the remaining will be x plus 1. Therefore, if you are going to multiply x minus 1 times x plus 1, then the same result are to be generated, and that is x squared minus 1, then multiplied by 2 here. Therefore, our LCD will be 2 times x squared minus 1, or 2 times the quantity x squared minus 1. Next, the LCD will be multiplied to our rational equation, both sides. Okay. Yan. And then same thing, after we multiply both sides, therefore, the given LCD will be divided by our denominator, then multiply the quotient to our numerator. Same thing to our second expression, which is the subtrahend. Okay, we do have 2 times x squared minus 1, no, 2 times the quantity x squared minus 1 divided by x minus 1, then multiplied to our numerator. And same thing with 1 over 2. Thus, we do have 2 times 2 minus 2 times the quantity x plus 1 times 1 is equal to x squared minus 1. How did we able to generate that result? First, the LCD divided by x squared, what left will be 2. Then, as a quotient, multiplied to 2. That's why we do have 2 times 2 minus the given LCD. Okay, now remember x squared minus 1 is the same as x plus 1 times x minus 1. Meaning, if we divide the given LCD to x minus 1, therefore, what left here will be x plus 1 times 2. That's why we do have x times 1 times 2 or 2 times x plus 1 multiplied to our numerator is equal to, next, the LCD divided by 2. What left will be the quotient x squared minus 1 multiplied to 1 using identity property for multiplication. The answer will be x squared minus 1. Any number multiplied to 1 will be the given number. Okay. Next, 2 times 2, we do have 4. Then we are going to apply distributive property here. We have 2 times x, 2x. 2 times 1, we do have 2. Then multiplied to 1, same result is to be generated. Then we have to open and close parentheses. Then subtract is equal to x squared minus 1. And next, 4 minus 2x minus 2. Since you have to change the operation, change the sign of your subtrahend. Therefore, minus 2x minus 2 is equal to x squared minus 1. And then, transpose negative 2x to the right side, making it positive 2x. Then transpose negative 2 to the right side, making it positive 2. Then equate it with 0. Okay, next. Okay, then we have x squared, bring down x squared. Next, bring down 2x. Then simplify negative 1 or minus 1, minus 4, then plus 2. Therefore, when you are going to add, this will become negative 1, negative 4, positive 2. Therefore, you do have negative 3. Thus, you do have 0 is equal to x squared plus 2x minus 3. And in this case, we are going to get the factors. That's why we recall the previous lessons about finding the factors of the given expressions, okay? Or the polynomial. In this case, you have to think of two numbers. Two numbers wherein if you are going to get the product, the answer will be negative 3. But when you are going to add, it will be positive 2. Therefore, looking at the sign of the product, it's negative, meaning the two numbers are different on signs. One is positive, the other one is negative. On the other hand, when you add the given two numbers, then the answer becomes 2. In this case, what are the two numbers? Which one is negative and which one is positive? Okay, very good. We do have positive 3 and negative 1. Thus, the factors are the following: x plus 3 and x minus 1. Therefore, 0 is equal to the product of the quantity x plus 3 times x minus 1. Then we are going to apply now the zero property of equality so that we can able to find the value of the unknown quantity, which is the variable x. Okay, 0 is equal to x plus 3. And then we do have 0 is equal to x minus 1. Next, we are going to transpose positive 3 to the left side, making it negative 3 is equal to x. That is our first value of the variable x. Next, transpose negative 1 in the left side, making it positive 1. Therefore, another value of the variable x. Thus, we do have negative 3 and positive 1. Okay. And then, since we're able to gather or we able to obtain the values of our variable x, which are negative 3 and positive 1, we are going to verify if the given value is true or extraneous solution. Now, we are going to use first negative 3. X is equal to negative 3. Therefore, we are going to substitute it in our rational equation. And here is my solution for the checking. We have 2 all over the quantity negative 3 squared. Remember, our x here is negative 3. We are going to provide an open and close parenthesis, then square it minus 1. Then the x here will become negative 3 minus 1. Next, negative 3 square it, or the square of negative 3 is equal to positive 9 minus 1. We do have 8. Remember, 2 over 8 is equal to 1/4. By simplifying the given fraction, since 2 and 8 is common to a number 2 as a factor. Okay, therefore we can divide 2 and 8 and we can simplify it into 1/4. Okay, next, we do have here 1 minus the quantity negative 3 minus 1. Negative 3 and negative 3 minus 1 will be negative 4. But since we do have subtraction here, we change the operation to addition. And the moment we change the operation to addition, the subtrahend sign also changes. Therefore, it becomes positive 4. Okay, then here we do have 1/4 coming from 2 over 8, 2 eighths plus another 1/4. Therefore, this is a similar fraction. 1 plus 1, we do have 2, right? It's 2 all over 4. Now, 2/4 is the same as 1/2. Therefore, 1/2 is equal to 1/2. Meaning, the value negative 3 for x is a solution to the given rational equation. Now, what about if x is 1? If x is positive 1, therefore we do have, okay, we do have substitution for the variable x, which is 1. Then we do have 1 squared. Now we have 1. Next, 1 minus 1. Therefore, it is 0. Remember that if our denominator is 0 and the numerator is not 0, therefore, we are going to generate undefined solution or undefined answer. Thus, positive 1 for the value of x is extraneous solution, meaning we cannot use x is equal to 1 for the reason that we are going to come up with undefined solution, which is not equal to our 1/2 as a result. Thus, the only value of x that we can use is negative 3. One is extraneous solution. Okay. Any question? None so far? Okay. Now, with that, let's go with self-check time. Now, this will be your performance task, and you are going to solve the following rational equation. And then try to submit this one to your teacher, and then verify if your answer is correct to the value of the variable x of the given rational equations. Always remember, when you are going to solve rational equations, first, get the LCD, the least common denominator. Second, multiply the LCD to both sides of our equation. Then third, solve the given equation. Fourth, always verify your solution, meaning to say you have to verify your value of the unknown, because if the value of the unknown is extraneous, then that is not a solution to the given rational equation. Okay? Now, what if we are going to integrate this concept, okay, dealing with problems? Okay. Now, I do have here a sample problem. Now, this is a problem. In an inter-barangay basketball league, the team from Barangay Uno has won 12 out of 20 games, and the winning percentage is 60%. How many games should they win in a row to improve their win percentage to 80%? I repeat, there is a team from Barangay Uno with 12 winning games out of 20 games. And the percentage of the winning is 60%. And they would like to know how many winning games, if they are going to play consecutively, how many winning games do they need in order for them to improve their winning percentage to 80%? Now, in this problem, we are going to provide a certain solution. Now, let x, we are going to represent the given unknown, or the number of additional winning games of Barangay Uno, or the team from Barangay Uno. Let x be the number of additional winning games of a team from Barangay Uno. Meaning to say, whatever be the value of that x, that represents to the winning or additional winning games of a particular team from Barangay Uno. And then we always go back with our informations, and that is 12 are the winning games, 20 is the total number of games, and that is 60%. And they want to improve their winning percentage to 80%, or 0.80 or 0.80. Now, in this case, we want to know how many will be the additional games and winning games. Meaning to say, consecutively, they have to win the games. How many? Okay. Then, since we do have now our rational equation, we are going to get our LCD. And our LCD here is 20 plus x. Now, 20 plus x is our LCD. We are going to multiply both sides by 20 plus x. Therefore, 20 plus x divided by 20 plus x, 1. Multiplied to our numerator, we do have 12 plus x is equal to the LCD, which is the LCD, which is 0.80 multiplied by our LCD, which is 20 plus x. Then we are going to apply distributive property for 0.80 multiplied to our quantity 20 plus x. Thus, we do have 12 plus x is equal to 0.80 times 20 is 16. 0.80 times x is 0.80x. Next, we are going to transpose 0.80x to the left side, making it negative or minus 0.80x is equal to transpose 12 right side, making it minus 12. Then this is 1x minus 0.80x is equal to 0.20x. On the other hand, 16 minus 12 is 4. Then divide both sides by 0.20. Thus, the value of x here will be equal to 20. Meaning to say, the team from Barangay Uno should win 20 consecutive games for 20 games so that the winning percentage will increase from 60% to 80%. Okay? Now remember, when we talk about rational equation is an equation containing at least one rational expression with a polynomial in the numerator and denominator. And if you want to solve rational equation, always remember the four procedures or four steps. Number one, get the LCD. Number two, use the LCD and multiply both sides by your LCD. Number three, solve the given equation. And number four, verify your solution if that is extraneous or not. And always remember, rational equation can be used to solve a variety of problems that involve rate, time, and work. With this, good day and God bless. Happy learning and see you in my next video learning episode. This is Bahagharing Lexi, waving everyone with a beautiful smile. God bless.